We've got two matrices, A and B, and we're asked to use A and B to disprove the proposition that matrix multiplication is commutative, i.e. show, this is what the question is basically saying, show AB is not equal to BA. So we need to work it out. Okay, first up, actually, let me write down. First up is going to be AB. I'm going to do this by hand, but you could actually just put it in your calculator. Okay, but it's quite a quick one. So we're going to get minus 5 over 13, 12 over 13, 12 over 13, and 5 over 13. Be really careful. I nearly missed that. That's a negative here. Just going to make it a bit clearer. Minus 5 over 13, minus 12 over 13. To be fair, we've shown it at this point because these are not the same, but let's just finish it off. Okay, I'm not going into lots of detail on how I'm doing this. I'm just doing your standard 2 by 2 matrix multiplication. AB not equal to BA proposition disproved. Let's make it really clear that we have done it. Okay, part B. It says matrix B represents a transformation T subscript B. Describe it. Well, when you look at this kind of thing, you can see it's not going to be like a simple reflection or even an enlargement. It's not a shear either. And because you've got sort of similar numbers, but some positives and negatives, what should be jumping at you is the idea of a rotation. And there's this formula in the formula book. It says if you want to do an anti-clockwise rotation through theta about the origin, then you get this. And so we can see it works if cos theta is 5 over 3. Sorry, 5 over 13, I think it was. And sine theta is 12 over 13. Now we have to solve these. Actually, there are more than one solution, but because they're both positive, that's sine and that's cos, then we must be less than 90 degrees. So actually, I don't need to find both solutions. I can just find one by doing inverse cos of 5 over 13. It doesn't say whether to use radians or degrees, so I'm just going to stick with degrees. 67.3801. So just to finish it off, it's a rotation by 67.4 degrees actually I've missed the anti-clockwise bit. Rotation, anti-clockwise, by 67.4 degrees. I do need to still say where it's about the origin O. Now, by considering the inverse transformation of TB, determine B minus 1. Note, you can't just find the inverse matrix. It says by considering the inverse transformation, you must use that. The inverse transformation well, there's two ways you could do it. You could either do clockwise. You could do well, it would be clockwise by 67.4 degrees, or actually, because we want to work in terms of anti-clockwise, it can be anti-clockwise by minus 67.38, i.e. minus theta. You could also do anti-clockwise by 360 minus this. It's a little bit more work. Actually, the quickest way to do it is going to be simply to do the following. It's going to be cos minus theta minus sine minus theta sine minus theta and cos minus theta. Now actually cos is an even function. Here it is, because it's like a reflection in the y-axis. So cos minus theta is the same as cos theta. So both of these stay the same. Sine theta is an odd function. It's actually anti-symmetrical about the y-axis. So this becomes sine minus theta is actually minus sine theta. And here we get a double negative. So we can simply just take our starting values. Where were they? Where have they gone? 5 over 13, 5 over 13, and we'll just swap these two around. There we go. If you didn't spot that, then you could, like I said, you could do 360 minus that answer. Okay, and that is the angle. And then you could find cos and sine of that angle. Cos of the angle would be the same. It would be 5 over 13. And sine of the angle, you can see we get this minus 12 over 13 ready to put there. So that's an option as well. If you don't spot to do what I just did there, you can substitute the numbers in. It's absolutely fine. Just make sure you don't round, because we want to leave it in nice fractional form. Having said that, actually, I think the mark scheme allows the answer to be written, say, to 3 significant figures here. So don't stress about it, but this is the preferred one. Finally, we've got a different matrix C. I'm going to grab this. Okay, this is actually going to be a stretch. Oh, actually, it's got a negative in there as well, so no, it's even more complicated than that, but sort of a kind of a inverted stretch going on. So we've got a transformation BC, which is TC followed by TB. So if I was multiplying a matrix, I would multiply by TC first and then TB afterwards. So I'm going to write it like that. Now, an object shape of area 5 is transformed by this matrix to an image shape n. Determine the area of n. For this, we need essentially the scale factor, and that is given by the determinant of this TBC. Now there's two ways to deal with this. You could multiply matrix B by C and then work out the determinant, or you could use a neat little result in that if you multiply two matrices together and you find the determinant, it's the same as if you find the determinant of this first matrix and times it by the determinant of this second matrix. And that is really useful because TB was a rotation, remember. So this does not change the area, and I don't even need to check. This will equal 1. I mean, you can check if you want. It won't take long. But that will equal 1. Well, this thing here, well, it's just 1 times minus 3. So it's minus 3. Okay, that's it. So the area of n will equal the original area multiplied by 3, which is 15. That is the final answer. You could write 15 units squared if you want. It doesn't talk about a measurement. Notice the minus 3 means it is inverted. It sort of means it's like when you do a rotation, basically, by 180 degrees, it ends up being upside down. So that would be the effect of this transformation, but the minus doesn't actually affect the area; it just affects the orientation at the end. So, like I said, I'm not going to go through it, but you could, if you didn't realize that, of course, you could actually multiply the matrices together. This one times this second one, and you would again get minus 3. You just have to make sure you don't include that negative.